In this video, we're going to learn how to integrate AWS IoT with Amazon Sumerian. Today, I am joined by Tim Wilson, who's a product manager for the Innovation Lab. Tim, you are on camera.
Howdy.
How's it going? Thanks for coming over to give us a quick demo of this scene that we're using, that you've built using AWS IoT and Amazon Sumerian. So in this video, Tim is going to show you how he controls a conveyor belt using an Amazon Sumerian scene. I'm going to throw it back over to you, Tim. If you could just hold up that conveyor belt, kind of show what it is. And so yeah, he built this conveyor belt. Move it a little bit over. There we go. Yeah, so this conveyor belt is controlled using a mobile app. Well, a Sumerian scene that can be used in a mobile app. And it's also integrated with AWS IoT, and that's kind of how it's controlled. And so that's what we're going to be looking at today. And so what we are going to actually be looking at is the AWS console and how that is connected to Sumerian, as well as how we actually built, or how Tim built this scene in Amazon Sumerian. Tim, can you just give us a rundown, and we'll show this this video of this actually in action. Can you give us a rundown of what this scene or what this project does?
Sure. Yeah, so we built this conveyor belt in our lab. It's actually it's 3D printed. We designed the model for the conveyor belt in Autodesk's Fusion 360. We used the AWS IoT service to control the state of the conveyor belt via an IoT device shadows. And so we can actually manipulate the shadow in the Sumerian application, and then the model or the scene can actually reflect the state of the conveyor belt. So if it's moving forward, it will show arrows that move forward. If you put in reverse, the arrows will change directions. It will also, if you could put the conveyor belt in an error state, basically stall out the belt, and it simulates a belt kind of slip situation. And the scene will pick up on that error and then show a troubleshooting animation inside the scene. So if you think about like a technician in the field getting, kind of quick access to troubleshooting animations and walkthroughs via a Sumerian scene.
Great. Well, let's move on to actually how you built this scene utilizing both AWS IoT, and then we're going to move over into Amazon Sumerian. So let's get started.
What you're looking at here is the AWS IoT console, and we're actually looking at the IoT thing for the conveyor belt. And this is what you can see here is the shadow document, which contains the desired and reported state of the conveyor belt. And so if I go into the document and change mode from stop to forward, hit save, the conveyor belt is actually going to pick that up and then pick up the change in the desired state and set the belt in motion. And so what you can't see on camera here is actually the conveyor belt right next to me is moving forward. Similarly, I can come back and change that mode back to stop, and the conveyor belt will pick that up and then report back in the reported state that it is indeed stopped.
And it is stopped, correct?
Yes, the conveyor belt just stopped. So this is the shadow state. This is the shadow document. We can use this information to both control the conveyor belt via a Sumerian scene, but then we can also use the information, the state information, to trigger animations and build out kind of what you would call like a digital twin representation of the conveyor belt in Sumerian. So let's move over to the Sumerian console, and I'll show you kind of the rough, or give you an overview of how we organized the conveyor, the scene, and how we imported the conveyor belt model. So I mentioned before, we designed this conveyor belt in Autodesk's Fusion 360 product that allowed us to create the 3D models to actually 3D print this conveyor belt, but also we could export FBX and OBJ files that we could then import into Sumerian to then build animations and ultimately build the scene.
Right. So the cool thing is, though, this model was constructed with multiple different parts. Actually, before we get that, let's look at how you actually you used a existing Sumerian tutorial to connect this scene with your AWS Thing Shadow. And you can find that tutorial listed in the description of this video. If you could just quickly show where that is. So the top level entity you see, Conveyor Digital Twin. Then under the AWS configuration, you'll see Cognito Identity Pool ID, which he's not going to show, but that is, if you follow that tutorial, you'll get a Cognito Identity Pool ID and you can plug it in there. And then also below that, the IoT data client is enabled. And so that's how it's the simple steps to connect this with your AWS Thing Shadow. All right, Tim, can you describe to us how this is kind of built out, this model?
Sure. Yeah, so we as I mentioned, we imported on a OBJ file from Fusion 360 into the scene. That gave us all the components for the conveyor belt, 3D model components of the conveyor belt. I then organized this in kind of a rough hierarchy where we have conveyor parts, as you can see there, quite a few of them. So they're kind of, each part is about three entities deep. So the at the root here is the actual mesh where we can manipulate materials and things like that. Yeah, so we also have, I've grouped what I'm calling annotations, which consist of these arrows and kind of things that are external to the conveyor belt that show the state that it's in and kind of give you more information about what the conveyor belt's doing. We also kind of pull in the shadow data from IoT. We created a empty element which actually goes out, and this is a script that is part of a state machine. I'll open that right now. And so this is a script that runs every second or so, and it goes out and grabs the shadow information from the IoT service and then sets it as a global variable in the Sumerian service, which we can then use, that variable we can then use to trigger various animations and different states of the scene.
And so this behavior is constantly running, right?
Correct. This is constantly looping. And we decided to do that because we were using multiple elements and we didn't want to run a kind of like a get shadow script for each time we wanted some different part of the shadow. So we decided to get it all at once and save it as a global variable. From here, I'll show where kind of one of the main parts of the scene, which is showing the forward and reverse states via this arrow annotation, as we call it. Yeah, so in the case of these arrows, they're simple state machines. Yeah, this is fairly simple, and so we're actually able to use a state machine to just move and then reset the position of these arrows when they pick up the state of the conveyor belt. And so what we show here is a simple move and reset, and so this is just constantly running. We actually, initially, if the conveyor belt's not actually running, if it's not in motion, we will hide this animation or this state, essentially this animation that we created via a state machine. And so if we go up one more level here, we have this show behavior, and this is where we're checking the global variable that we have set when we, I mentioned earlier that we have this entity that just sets the variable or sets the shadow state every second into a global variable, and then in this state machine we check whether that variable is going forward, going in reverse, and depending on what that variable is, we will show or hide those arrows. If it shows, then it shows that animation that's going. So that's how we built the kind of directional arrow annotation, as we call it.
There's something really neat about this is that when you grip it, and the viewers probably saw that when you stop the conveyor belt from running, an error message pops up.
Yep.
And that is using an animation, which is what I was thinking before, a timeline animation. So let's move on to looking the high level. Timelines can be very detailed, but let's look at the high level of how that's constructed.
Where we actually start on that is we expose a pick event. So to play that animation, a user will actually click on what I call this belt cover or drive belt cover. And so if I open that, I have a specific behavior that's looking at the shadow variable. And if it's in error, then I allow a pick event to happen on that drive belt cover. And if a user does do that pick, I do a couple things here. So I emit a message to this particular channel, which will then be picked up by another. This is the channel I call it pick belt cover. And then what's also nice about this scene is that it's not just interactive. I can click on things. I actually get a narration about different events. So I can, when I pick on the belt cover, which will then trigger an animation and I'll show that in a second. I also start a narration, basically how to troubleshoot this error code. And so that's using the speech function in Sumerian. So if I follow this, I go to pick belt cover. So what I'll do here, I'll collapse this back down, and I want to look at my conveyor timelines. So to show that error animation, I have simple animation which actually pulls the belt cover away. And so I'll show here, we have this, we need to know when to pull it away. So I listen for that pick belt cover event, and then that will trigger a start timeline event. And if I look at the actual timeline, it's pretty simple. We simply pull that belt cover away to expose the internal components. But one of the key parts to this is that we actually have a much more complex animation of this wrench going through and tightening or loosening and tightening these screws. And so instead of doing that as one big animation, pulling the belt cover away and then doing all that work, I split it into two parts. And with timelines, you can emit messages on channels. So I have another message that gets emitted that's called belt cover open. And so I can actually time that however I want. So I put a keyframe there.
So that message channel emits a message that fires another or starts another timeline. So let's look at the next timeline.
Yeah, so if I go back to my entities, and then so that's belt cover open, then I have this a little bit more involved timeline.
We don't want to look at the full detail of this, but if you could just scrub through that just to show what it is. And there's also a narration, a separate, there's a separate state machine behavior that has been triggered, and so there's a narration going on at the same time.
Correct. Yeah, and so this goes through animating this hex wrench and the screws to show a technician or someone in training how to troubleshoot this problem.
Looks like you also have forward, stop, and reverse buttons.
So we initially built the scene to just be a kind of a passive, just reflect the state that the conveyor belt's in. We then decided through these HTML entities to provide essentially controls within the scene. So with these HTML entities, we can create buttons, and then basically we put pick events on them so that when a user picks the forward button.
When you say pick, you mean either click with a mouse,
or tap on it with a
device.
A device. We can then fire off a script that will update the device shadow, the desired state of the device, to move it forward, stop it, or reverse it in this case.
Could we take a look at the script
Sure.
that you're referring to?
So in this action, I have an execute script action here, which will execute this what's called forward script. Basically, what this does is we have a function here called set motor state, which using the IoT SDK, we update the desired state of the device shadow. So we have state and speed, and then we pass that when we enter this function, we pass the forward and the speed, the forward command and the speed command that we want, and this is the device, the IoT thing name. So we pass that in, and via the IoT SDK integration with Sumerian, we're able to actually manipulate the shadow to control and operate this conveyor belt.
Essentially, it's the same thing with reverse.
Yeah, it's exactly, it's going to be the same thing for reverse or stop. We're just going to pass in different variables. And
so also in there's an error. So when you put your hand on the conveyor belt and stop it, there's an error message that runs. What happens on the back end on the IoT side when you stop the conveyor belt from moving? So in that case, the conveyor belt, the code that we have running on the conveyor belt is essentially looking for a difference between the state that it's in. So if it's moving forward, and the RPMs that it detects. So if it's supposed to be moving forward, but it essentially detects 0 RPMs, then it assumes that it's in a slipped or a stalled event or kind of a belt jam, and it shuts itself down or shuts the motor down and updates the shadow in the IoT service with an error code, and it basically says, we call it error 1, and it updates the shadow. So there's a reported part of the shadow document, and it updates the shadow with an error 1, which then the scene can pick up. So all these animations are triggered by that error message. Correct. Where is that error message posted in Sumerian, and so that all those different animations and those troubleshooting timelines and animations can pick up and start firing? Or where is it received in Sumerian? Yeah, so I mentioned before, we have an entity which is running a set shadow script, and so every second or so we run this script, which goes out and gets the thing shadow, and then we grab that document, and we parse that and save that as a Sumerian global variable. So we have a payload, which is the reported shadow, reported state from its shadow, and then other state machines can go and look at that variable and pick up the information that they need. So if that variable is set to error, then we can trigger a state machine and animations based off of that. So we did this just to limit the amount of times that we're going out and making calls to get the shadow. So we only do one call every second or so, and then a bunch of other state machines can then just look at the global variable versus independently going out to the IoT service. So I mentioned earlier that we have this set shadow global variable. So we're periodically getting the thing shadow. We save that to a global variable in Sumerian, and then other state machines can use that to trigger different events. So if we look at conveyor parts, we go to our drive belt cover, and I look at the state machine. This is the state machine that is going to check whether or not the conveyor belt is in error, and if it's in error, it then allows a pick action to happen. So if I look right here, we have a execute script condition, which looks at that global variable that I set earlier, and if it's in error, then I on the true condition,
it allows a pick event on that belt cover, which then allows the user to trigger the animation to the kind of troubleshooting animation that we created. And so what this allows us to do is then, instead of, as I mentioned earlier, having a lot of different state machines going out and, hitting the IoT service to get different information, we can kind of save all that information at once and then have our state machines look at just the global variable within Sumerian.
Right, and the last thing that I know we have is that anytime a user touches or taps or clicks the side of the model, that triggers like what you're calling an exploding animation. If you could describe that a little bit more.
Sure. So in this kind of same vein as, thinking of it like a technician who's troubleshooting this device, we built out the ability to kind of look at an exploded view of the conveyor belt. And so put pick events on both these sides. So there's these gray pieces. These entities have a pick event, which will trigger these, we have a back and a front explode timelines. So the pick event will trigger this, and kind of in sequential order, it will explode the model. And so if I go to the back explode, do the same thing. And so a user has a kind of an in-depth view of how this conveyor belt is made up. In addition to that, we've also put pick events on specific parts. And so if I look at this motor as an example here, there's a pick event where a user can tap or click that stepper motor, and they will get a narration about the specifics, like what model it is, its electrical characteristics, how many amps it can draw, and things like that.
Right. So just essentially click on it, pick it, click it, tap it.
Yep.
And you get some narrated metadata information.
Exactly.
Regarding that. And that is just one use case for creating a Sumerian scene to control using AWS IoT, an actual device to both receive data and update data, or things shadow information to control a device. For more information on how to get going on a project like this, there are two tutorials below in this description of this video that will allow you. One is a tutorial, well, both are tutorials. One is a tutorial for just setting up the Cognito Identity Pool ID in the CloudFormation template. The other is for conducting a similar demo, and so there's a tutorial there. So make sure you check that out for additional information to get started yourself. But essentially, thanks, Tim, for being in here and joining us and showing us how to use AWS IoT in conjunction with Amazon Sumerian.
Absolutely.
All right, all. Thanks for joining us, and make sure you're checking out the rest of our videos. We'll catch you later.